This Tates Academy is for 8.3. We'll look at guided practice problem 2 and guided practice problem 4, dealing with volume of pyramids. So first we'll look at number 2 here. A square pyramid has a height of 12 meters. If a side of the base measures 5.5 meters, what is the volume of a pyramid? So what we're looking at here, since it says it's a square pyramid, then that means the base of it is a square. And it's telling you that the side of the base measures 5.5, and again, since it's a square, then all the sides of the base are 5.5, and it tells you that it has a height of 12 meters. So the height would be dropping right down the middle and then landing and forming a 90-degree angle with the base, the square. And that measurement it's telling us is 12. So to find volume of a pyramid, it's the same as a prism, except it's only a third of it. So our formula is, again, volume equals capital B times how tall it is. And in this case, capital B, since it's a square, then volume equals, oops, I forgot the divided by 3 part. So your formula is volume equals capital B times H divided by 3, or you can use times a third, 1/3 times capital B times the height. So either one of those work. Most of you will probably prefer to use the divided by 3, but they both give you the same answer. And capital B, since it's a square, capital B here is length times width. Again, capital B is the area of the base. So we want to find out the area of the square, and then multiply that by how tall it is, and then divide that by 3, or multiply by a third. So the formula then, since it's a square-based pyramid, is length times width times the height divided by 3. And from there, we just fill in everything that we know. All right, so volume equals, the length is 5.5, the width is also 5.5, and the height is 12, and we divide now that by 3. So that's all the work that you would need to show, and then you type that all into your calculator, 5.5 squared, or 5.5 times 5.5 times 12, divided by 3, or times 1/3. When you do all of that math, you should get volume equals 121. So then we label it correctly, we should get 121 meters cubed. It is volume, so meters cubed, the small 3 after your units, meters. That's it, 121 meters cubed. Let's look at number 4 now. Next page. So if we look at number 4, similar problem here, except now it says that it's a rectangular pyramid. So again, it's the same scenario here, except now instead of the base being a square, it's a rectangle. So here's our pyramid, and if you need to draw it to help you out, go ahead and draw that. And I'm just doing it so you can see visually what's going on. So now they're giving us that the volume is 58 cubic meters. And it says that the sides of the base are 3 by 5. So 3 by 5. And again, it doesn't matter which one you call 3, which one you call 5. And then what they're asking us for is the height. So again, the height is this measurement right there. If you were to drop something from the very top, it would land in the center of the base and form a right angle. So that's what they're asking us to find. So once again, volume is, since it's a rectangular pyramid, length times width times height. Again, our overall volume is always volume is capital B times the height divided by 3. So to find capital B, it's length times width. Capital B equals length times width. If the base, when we get into cones, the base are circles. So for area of a circle, it's pi r squared. So the capital B always changes just depending on what shape the base is. So since it's a rectangle, length times width. So we have length times width times height, and we divide that by 3. Now, what's different this one than on number 2 is they're not asking us for the volume, they're asking us to find the height. So just fill in everything that you know. Okay, so they tell us the volume is 58, so we replace V with 58. Bring down your equal sign. Then we have our division bar there, and the length and the width, we know the length and width are 3 and 5. So 3 times 5, and we do not know the height, so that stays H. And then all of that is over 3. So then we do all of our math. Nothing to do on the left side, so that stays 58. 58 equals, and we would get 15, 3 times 5 is 15, times the h, so 15h. Again, number next to the variable means you're multiplying. All of that's over 3. And it's okay, we can go ahead and do 15 divided by 3 right now. So when we do that, we would get 58 equals 5h. 15 divided by 3 is 5. Now the goal here is to get the h all by itself. So 5 is multiplying the h, so to get rid of it, we would divide both sides by 5. These 5's cancel because they equal 1. 5 divided by 5 is 1, and then 1 times h would be h. And then you do 58 divided by 5, and you would get 11.6. So our answer would be 11.6 meters. And it's just meters because we're just talking about a height. We didn't find the area, we didn't find the volume, we just found the height of the pyramid to be 11.6 meters. Okay? And again, you can use 1/3 for that if you want to. So instead of the dividing by 3, you could do the times 1/3. I'll work that out for you real quick with the 1/3 in there. So you could have 1/3 times length times width times height. Again, multiplying by 1/3 is the same as dividing by 3. So the volume we know is 58 equals 1/3. Length is 3, width is 5, or vice versa. And we're just multiplying, so it doesn't matter which one you label, 3 or 5, times the height. So now you can see we would just multiply 1/3 times 3 times 5, and we would still get 5h, and then still divide by 5, 11.6 equals h. Again, make sure you're labeling. 11.6 meters is your height. So the key here is just use your formula, plug in everything you know, and then use your rules of algebra, solving equations, to get the variable all by itself. That's it for volume of pyramids.